Hello and Assalamualaikum. Today, me and my groupmates will be discussing about radio broadcasting for our Physics 260 video assignment.
Let's start with the history of radio broadcasting. The fascinating journey of radio broadcasting began in the late 19th century. In the 1860s, Maxwell theorized the existence of electromagnetic wave, and after 2 decades of the theorization, the theory has been confirmed by Henry Hertz. In 1890s, Nikola Tesla developed early radio wave technology in order to contributing to the foundation of the radio communication. Then in 1901, Guglielmo Marconi have made a significant stride in wireless telegraphy, achieving the first successful transatlantic radio communication. Early radio transmission. The first audio broadcast was conducted in December 24, 1996 in Massachusetts. Forrest invented the audio tube in 1996 that amplified weak radio signals and improved long-distance radio communication. After that, growth and regulation of radio broadcasting start from 1920s to 1940s. Period between 1930s to 1940 was the golden age of radio, featuring dramas, comedies, news, and variety show. During a World War period, radio played very crucial roles in disseminating news and propagandas during the war. After the war, for the post-war changes, Edwin Armstrong developed frequency modulation or FM in 1930s. It gained popularity due to its superior sound quality over an AM radio. Lastly, invention of the transistor radio in 1947 led to portable radios, making radio more accessible and personal.
We move to the next part, which is technology in radio broadcasting. First, we have a digital broadcasting. Digital broadcasting technology like DAB, HD radio, and DRM offer a higher audio quality, more channels, and additional features like text information and metadata alongside the audio stream. Second, we have automation and playout system. Playout system are in charge of converting and playing source media to an external on-air environment such as TV and radio. Although it performs similar function as a media player, for example CD and DVD player, a playout system goes beyond. It's a compared other feature useful for the broadcast of content. Connecting playout system to other press NRC allow producer to control the position, timing, and latency of media item, play multiple element, schedule media item to be aired, create and a playlist, newscast, broadcast. It also allow the producer to keep the story and the graphic multimedia piece synchronized. Third, we have a communication satellite. Communication satellite is a transmission and a detection of communication signal consisting of electromagnetic waves that travel through the air in a straight line or by reflection. For example, radio location satellite and broadcasting satellite service. Lastly, we have a transmitter and antenna technology. The station transmitters send the music to the antenna in the form of electric current at desired frequency. The antenna converts the electric current to the radio wave that are transmitted out all in one direction. For example, a radio station might broadcast music as an AM signal, which is type of radio wave in the EM spectrum.
Next, we continue with the current practice of radio broadcasting. So first, we have digital transition. Many radio stations have transitioned to the digital broadcasting that offering clearer sound quality and additional channels. Digital radio standards like DAB, or known as digital audio broadcasting, and HD radio are becoming more prevalent. Second, we have streaming and podcasting. Radio stations often stream their broadcast online, reaching a global audience. Additionally, many radio programs are repackaged as podcasts and allowing listeners to access content on demand. For the third example of current practice of radio broadcasting, we have integration with smart device. Many modern radio are equipped with the internet connectivity that allow the seamless integration with smart device and voice assistants. This enable the features like voice control tuning and personalized recommendation. And the last one you have remote broadcasting. It is an advance in technology have made a remote broadcasting easier and more affordable. Radio hosts can broadcast from virtually anywhere with internet connection, facilitating live coverage of events and interviews.
Now I'm going to explain to you what is the difference between AM and FM. So first, what is AM? AM is amplitude modulation. The definition is in AM, the amplitude, which is the signal strength of the carrier wave, is varied in proportion to the waveform being sent, such as sound signal. Next is how does this works? The amplitude of the carrier wave changes according to the amplitude of the input signal. The frequency and phase of the carrier wave remain constant. For the advantages of AM is that AM is simpler to implement and can be received by simple receivers. It has a longer range which is useful for reaching distant areas. The disadvantages of AM is more susceptible to noise and interference because noise typically affects amplitude. The sound quality of AM is lowered compared to FM. The application of AM is it is commonly used in talk radios, news broadcasting, and other spoken word formats. Next, what is FM? FM is frequency modulation. In FM, the frequency of the carrier wave is varied in accordance with the amplitude of the input signal. How this works is that the frequency of the carrier wave changes in line with the input signal, while the amplitude remains constant. The advantages of FM is it is less susceptible to noise and interference because most noise affects amplitude, not frequency. It provides better sound quality, especially for music. The disadvantages of FM is that it requires a more complex receiver and has a shorter range compared to AM. The application of FM is that it is commonly used for music broadcasting and high fidelity sound transmissions, such as in FM radio stations.
Okay, next we have digital radio transmission. Digital radio involves transforming sound into numerical patterns or digits as opposed to the analog method where sound is converted into electrical signals resembling wave. This transition offers advantages such as increased resistance to interference and the elimination of imperfections associated with analog transmission and reception. Although digital radio signals may encounter interference in remote areas from the transmitter, they generally provide superior sound quality. Okay, so how is digital radio transmitted? Digital radio transmission involves broadcasting audio signals over the airwaves using electromagnetic radiation. This process begins with the generation of a carrier wave by a radio transmitter, which is then modulated with digital audio data. Multiple audio channels may be multiplexed together for transmission. The modulated signal is broadcasted via antennas propagating through the atmosphere. Various factors like terrain and atmospheric condition can affect signal propagation. At the receiving end, radios capture the transmitted signal, which is then demodulated and decoded to extract the original audio. Throughout this process, adherence to regulatory standards ensures legal and interference-free transmission.